Greetings to Dr. Nur Habibah, our lecturer. Today, me and my fellow group members from Group 24 have gathered to present two main topics with questions and solutions from our subject Engineering Mathematics 2. The topics that we'll be covering are triple integral in cylindrical coordinates and Green's theorem. Without further ado, I would like to call out my fellow group member Muhammad Ashraff bin Nasruddin to proceed with the presentation.
Assalamualaikum and greetings. Hi, my name is Muhammad Ashraff bin Nasruddin, and now I will talk about the first question for the topics of triple integral in cylindrical coordinates. Okay, the first question is about the hot air balloon, where we need to find the volume of it. So in question A, we need to consider each part of the balloon separately. So we've divided the hot air balloon into two parts, which is the half sphere as the top part, and then the frustum cone as the bottom part. We will solve the top part first, which is the half sphere. Okay, since the half sphere have the dimension of the z-axis is 28, so the equation for the z-axis for the half sphere is square root 784 minus x squared minus y squared. So in this question, we need to solve it using cylindrical coordinate. So we need to convert the x and y axis into the r and theta component. So the new equation for the z-axis is square root 784 minus r squared. Then we solve the question by finding its limit for the dz, dr and d theta. So for the limit for dz is 0 to square root 784 minus r squared. Then the radius limit for the radius is from 0 to 28. And lastly, the limit for theta is from 0 to 2 pi, since it's full circle. So we solve the integral of the dz first, the z. So then we will get r bracket 784 minus r squared power of 1 over 2. Okay, then we will solve the dr. By using u substitution, we will get the equation of negative 1 over 2 du equals to r dr. Then we will change the r dr into du. Then we will solve the integral of the du. Then we will get 21952 over 3 d theta. Then we will solve the integral of the d theta. Then the final answer we will get for the top part of the balloon, the volume is 45976.16 cubic feet. Okay, now we will solve the bottom part of the balloon, which is the frustum cone. Okay, the arrangement for the dr, dz, d theta in this question is quite different. For this answer, I arrange it into dr, dz, and d theta. So the limit for the frustum cone is from 0 to z over 2 plus 28. Since the frustum cone has two different radius, so the limits for the radius is written this way. Then for the dz, the limit for the z is from negative 44 to 0, and for the theta is from 0 to 2 pi. Okay, then we will solve the dr first. Then we will get the answer for the integral of dr. Then it will be z squared over 8 plus 14z plus 392 dz d theta. Then we will solve the integral of the dz. Then we will get 21,736 over 3 d theta. After that, we solve the theta. Then we will get the volume for the bottom part, which is the frustum cone is 45523.777 cubic feet. And now to complete the answer for the question of the hot air balloon, we need to find the volume of the hot air balloon. So we need to total up the volume from the top part and the bottom part. So the volume for the top part balloon is 45976.16 plus with the volume of the bottom part of the balloon, which is 45523.77. Then the total volume for the hot air balloon will be 91,500 cubic feet. Okay, that's all from me. I will hand over the presentation to my fellow members, Yuva.
The second part of the question is asking to verify the answers in A by using formulas of volume of sphere, which is V equals to 4 per 3 pi r cube, and volume of cone, which is V equals to 1 per 3 pi r squared times h. We can now consider V is equals to volume of the entire balloon, V1 as the volume of the upper part of the balloon, V2 volume of the bottom part of the balloon, Ra as the radius of the upper part of the balloon, Rb as the radius of the lower part of the balloon, and h, which is height of the cone of the balloon. By considering this, we can now solve for the volume of the upper part of the balloon, which is V1. The formula used is 2 per 3 pi Ra cube. By plugging in the information given, we can now solve it, and the answer is 45952.85 cubic feet. While then, we can use the formula of V2 equals to 1 per 3 pi h times by Ra squared added by Rb squared added by Ra times Rb. This is to find out the volume of the lower part of the balloon. Then we plug in the information. The answer is 45500.70 cubic feet. Therefore, the volume of the entire balloon can be found by adding both V1 and V2. So by adding it, we get approximately 91500 cubic feet. Hence, it is proved.
Okay, now we will continue on the second topic, which is the divergence theorem, Green theorem. So the question shown the line integral of the electric field lines of the electrostatics.
Assalamualaikum warahmatullahi wabarakatuh. My name is Fahmi bin Fairuz. So for question 3, we need to evaluate this question where C is in the triangular with vertices with coordinate 0, 0, 1, 0, 1, 3, which is positively oriented. So first of all, we need to sketch a graph with the coordinate 0, 0, 1, 0 and 1, 3. So after we sketch the graph with this coordinate, we get the triangular shape of in the graph, so we can conclude the limits of the graph. So we use the equation of Green theorems, which is PdX plus Qdy equal to W integrate differentiate Q over differentiate X minus differentiate P over differentiate Y dA. So for these two equations P, we use set 1 plus X power of 3, so we need to differentiate with the respect of Y, so the answer is 0. So for Q, we use 2xy, so we need to differentiate with the respect of X, so we get 2y. So we can conclude using the Green theorem, we need to get the limit, so we use type of origin. So we can get for y axis 0 to 3x, for x axis is 0 to 1. So we get 2y minus 0 dy dx, so we need to differentiate in the respect of y, so we get the answer, and then we get the answer, so we need to differentiate with the respect of x, and then we get the answer is equal to 3. So next is question 3a2. So we need to evaluate these two equations, y plus exponent power of set x dx plus 2x plus cos y power of 2 dy, where c is the boundary of the regayun enclosed by the parabola y equal to x power of 2 and x equal to y power of 2. So first of all, we need to sketch a graph for this equation. So we get the limits using the type of origin 0 to 1 and x power of 2 to the third x. So using the green theorem, we get the equation for p is y plus exponential third x. We need to differentiate to the respect of y, so we get 1. And then for the equation q, 2x plus cos y square, we need to differentiate to the respect of x, so we get the answer 2. So after we put the answer for p and q into the green theorems, so we get the equation, and then we need to differentiate to the respect of y, and then after we solve to the respect of y, we need to solve to the respect of x, which is to the limit of 0 to 1, and then we get the answer 1/3. Thank you.
Okay, so I will explain to you the solution of question B, which is determine the value of for which f x y z equals to 2x square y plus z square times I and plus x y square minus with x square z times g plus with ax y z minus 2x square y square times k is the vector field of an incompressible fluid with divergence f equals to 0. Since divergence f equals to 0, so divergence equals to derivative time with vector function equals to 0. So we can see that d over dx 2x square y plus z square plus d over dy x y square minus x square z, and add with d over dx ax y z minus with 2x square y square. So after we solve it, we can get 4xy plus 2xy plus with axy. So we added the 4xy with 2xy, so we get 6xy plus axy. Then we move it the axy because it's constant to the left, so we get it negative axy equals to 6xy. So we can cut it the xy, and we must remain the constant to the positive, so we get it a equals to minus 6.
Assalamualaikum and greetings. My name is Muhammad Amirul Haziq bin Muhammad Asnawi. I'm going to present the last question, which is C1 and C2. For C1, the question is, given a vector field Vxy equals to xi plus 2j, determine the curl V. To find curl V, it involves the cross product between derivative and the vector function. So we arrange the ijk as shown, differentiate with respect to x and the I, differentiate with respect to y and the j, and differentiate with respect to z and the k. The value of I is x, the value of j is 2, and there is no value for k, so we put it as 0. The value of the cross product is 0 minus 0 for I, 0 minus 0 for j, and 0 minus 0 for k. So the value is 0. For question C2, if V represents the surface velocity for the flow of river, and based on the finding in C1, describe the motion of a floating leaf along the streamlines. So the streamlines is given by dx over x equals to dy over 2. So we integrate both sides, and we get ln x equals to 1 over 2 y plus constant. So we rearrange the equation to become yx equals to 2 ln x minus 2 constant, 2c. So a floating leaf along the streamlines obedient the curve yx equals to 2 ln x minus 2c. I think that's all from us. Thank you for your attention. Have a nice day.